Hi, everyone, and welcome. My name is Glenn Deason, and I have the great pleasure today to welcome Theodore Postol to the program, who is a renowned MIT professor who also worked for the Pentagon as an expert on nuclear weapon systems, ballistic missile defense, submarine warfare, and other related areas, which will become even more important in the not too distant future. And I guess also appropriate to add that you've been very critical of developments within these areas over the past 2 years as well. So I really wanted to speak to you today about nuclear escalation and the general direction the world is moving. And I noticed that during the Ukraine war, there's been endless pleas from various Western leaders that we should be less fearful of escalation. I thought it would be wiser to be more worried. Anyways, you have a presentation that you are preparing to give all around the world
Right.
on the rapid escalation of nuclear weapons during the Able Archer exercise of 1983. And I think that this historical event is a very important case in terms of what could happen, not just within the next few decades, but the next few years, if not months. So I think this is a very, very important story, which unfortunately not enough people are familiar with. So, yeah, Professor Postol, I'm really excited to be able to speak with you today and to get to some insights into your presentation before you start presenting around the world.
Well, thank you very much for the opportunity to present it here. I should say that because of the complexity of this matter and uh, I have many slides in this briefing that I will not show because obviously there's a practical problem for me and your audience. But what I can do for those who are interested is I can mail a PDF, email a PDF of the file to any of your readers or your audience who's interested. All you need to do is send me an email. Just it's my address is postol at mit.edu. Only mistake you can make is to spell my name Postal instead of OL. So it's Postol at mit.edu. Now, because I have in the past been inundated with requests, which is I'm happy to answer, uh, please put on the on your title simply Able Archer Briefing. So, because I just, I only have so much time to sort through things, but if I have that information, it's just straightforward for me to just reply with the briefing. So just be sure to make it easy for me and easy for you to identify your request. And in any case, so what I will do today, with hopefully encouraging Glenn to interrupt me, um, is to present you some thoughts which are still being formed in my mind about Able Archer and its relevance to the situation today. And it's very relevant. Let me just explain what Able Archer is. Able Archer was an exercise. It was an exercise that occurred in 1983. So what happened is the way these exercises are done is you have a red team and a blue team. The blue team are the Americans or the Western Alliance. The red team is in this case, was the Soviet Union because the Soviet Union existed at that time, and and of course the Warsaw Pact as well at that time. And there is a an intermediary group that acts as referees during these tabletop exercise. So, for example, if you're the American Secretary of Defense, which incidentally, who actually participated, Caspar Weinberger, the then Secretary of Defense, was actually a participant in this exercise, along with the then chair of the Joint Chiefs, John Vesey. So these were real participants at the top of the U.S. government involved. And of course, they knew it was an exercise, but they also knew it was a serious exercise. And they were involved in the decision making, which then led to the evolution of the game. And I'll show you in very brief terms how the game played out. And the important lesson from the way the game played out is that the escalation, both sides were eye to eye, eyeball to eyeball, so to speak, in a military confrontation that was initially conventional. And then it was decided by the Allies, the Western Alliance, to use a small number of nuclear weapons in order to show the advancing Soviet forces that the West meant to stop them. The postulated situation was that the Soviet forces were in a conventional advance on Western Europe, and they were making very significant progress. They were already in the area of Hamburg when the United States first decided to use nuclear artillery to cause them to pause, to cause the Russians to pause, the Soviets to pause. So this is a scenario. It's invented. My own view, to be honest, is that the Soviet Union would have never done this. This would have not have been the kind of Soviet attack that was postulated. The Soviets were not nearly as capable as was being assumed at the time, and but that was the scenario that was invented, and it's important to keep that in mind, not because it isn't plausible that there would be such an escalation, but it's important to keep it in mind that the Russians today do not have the kind of threat to Western Europe that was postulated at a time when they also did not have that kind of threat to Western Europe. Right now, we are seeing people who should be responsible in political leadership roles talking about the possibility that Putin's next step after he somehow takes Ukraine, which has never been his intention, and the history shows that, but that somehow Putin will then sweep into Western Europe. And this is why Western Europe needs to escalate its commitment to a military buildup in preparation for dealing with the Russian invasion that is predicted by these people to be a possibility. And there is no reason to believe that the Russians are capable of this kind of invasion. There is no reason to believe that they intend to execute this kind of invasion. But the important point is that they do not have the capabilities to do this. And if they were ever to start building those capabilities, we would know it. And we would know it for years. So there is no reason to react to these kinds of false and phony scenarios that will cause a potential Russian reaction. So we could have an action-reaction cycle if people are unwise. But this would take place over many years, probably at least a decade. And we don't need it. And for economic reasons, as Glenn could discuss with much more wisdom than I could, this will have a catastrophic effect on Western Europe's current economic situation, which is already bad because of the war. So there's a lot of issues surrounding this false threat of a Russian invasion that comes to fore when you start looking at the situation. But for now, let me just focus on the situation with regard to Able Archer. The inspiration, if you want to call it, or the re-examination of Able Archer uh, came for me when the United States announced that it was going to, with Germany, that it was going to reintroduce Theodore missiles into Europe in Germany in 2026. To my knowledge, there has been no statement about these missiles being nuclear, but let me assure your audience there is absolutely no way that these missiles would not be nuclear. So this is a ploy on the part of political decision makers in Germany and in the United States to not inform the European public that nuclear ballistic missiles and cruise missiles will be deployed if the plans are not changed in Germany starting in 2026. Now, why do I say they have to be nuclear? The reason is that these missiles have absolutely no military capability of consequence if they are not nuclear. They must be nuclear. As you will see from some of the diagrams I'll show you, nuclear weapons are the only weapons powerful enough to make a significant military difference if you're going to introduce them into Germany. So they must be nuclear. And any questions uh, about them not being nuclear are overtly obvious when you look at the effects of nuclear weapons. Now, an important point that I will emphasize in this talk is the effects of nuclear weapons. And the effects of nuclear weapons are tremendous relative to anything your audience thinks they understand. Unless you have worked with nuclear weapons as I have, and some people may have, but almost everybody I deal with, including people, incidentally, from the American nuclear weapons labs who build these weapons. And then when I give a talk on the subject, they're stunned. So it's a very interesting thing. Studying the nuclear weapons effects is an important, different subject than the nuclear weapons themselves. But there are three effects of nuclear weapons that make them extraordinarily lethal. Any one of these effects would be extraordinarily lethal, but all three of them together make these weapons essentially perfect killers of people in urban areas if those urban areas were attacked with nuclear weapons. And those urban areas would absolutely, with certainty, be attacked because those urban areas, they contain command centers, they contain industrial facilities, they contain staging areas, they contain communication sites, they contain docks and other facilities, train hubs. There is no way that these centers wouldn't be attacked. We might call them, in the terminology that was used in nuclear planning, they were called urban industrial sites. That was just a name for cities. And it's important to understand. I'll use some of the language to alert your audience to the ways that these things are described, where that mislead a non-expert. I'm talking about a non-expert as an intelligent person who has simply not been versed in the details. Well, the most serious and lethal of these effects of a nuclear weapon. Number one is the thermal flash, the light and heat from the nuclear fireball. I'll just show you what a fireball is later in the talk so you'll get a sense of what it is. But this thermal flash, this extraordinarily brilliant flash of light, which in the target area will be thousands of times brighter than the sun at noon. Okay, so it won't be for a short time, but something brighter than the sun by 1,000 times at noon, at a desert sun at noon, will cause things to burst into flames. And these fires will be set essentially over the complete target area if it's a city. And so imagine you have an environment where fires have been set over over an enormous range to ranges of perhaps 6 or 7 or 8 kilometers for a near 800 kiloton warhead, which would be closer to a strategic warhead. 4 or 5 kilometers range for a 100 kiloton warhead. 2 or 3 kilometers range for a 10 kiloton warhead. And those are the rough ranges of the warheads that would be used. So a tactical nuclear warhead might set fires if it was used in an urban environment, that is to say, on a facility in a city, might set fires for a 2.5, 3 kilometer range. So 2 kilometers range would be, 12 or 13 or 14 square kilometers, all set on fire in one instant. And I'll describe these fires because they have a dynamic of their own. What happens is you have everything on, it's like being in a fireplace. That's the way to think of it. You're in a fireplace. And in the fireplace, there are enormously high winds generated by the upward motion of hot air, from heated air from the burning region around you. And the air temperature in the city will get above the boiling point of water in the streets, and the winds will be of hurricane force. Nobody survives that. So that's the most lethal environment immediately created by a nuclear explosion. The next most lethal environment is the radioactive fallout that occurs in the immediate target facility and downwind. But in the immediate target area, within an hour or so, radioactive materials will fall to the ground from the nuclear detonation. And the activity created from a nuclear explosion is hundreds or thousands of times larger than the activity that was released in the Chernobyl accident in 1986. In that time, it decays very rapidly relative to the radioactive decay at Chernobyl because of it's a different mix of radioisotopes. But what matters, the first hours to tens of hours after the attack, this stuff is falling right in the target area and downwind, tens of miles downwind, and in some cases, hundreds of miles downwind. So this radioactivity is very lethal and very consequential in terms of people who are caught in the target area. Then the least lethal effect, which is generally gets the attention of most people, is the blast wave. I'll describe the blast wave, but you should understand from the beginning that the blast wave, which is extraordinarily violent and long range, is really the least of the threats to survival that an individual unfortunate enough to be in the target area would have to contend with. And of course, the combined effects of all three of these effects would result in essentially the death of really essentially everybody in these target areas. There would be no survivors to speak of. So if but let me jump immediately to the question of Able Archer, because that's I want to give you a sense of the physical consequences of this experience in 1983. Now, so this is in some sense a technical rendition of what would have actually occurred if this war game had played out as a real military confrontation in 1983. Because now it's important to keep in mind that there is a social and political factor in my description here. The fact is, the fact that is overwhelmingly important, that is in some sense technical, but also social and political and military, is that these nuclear weapons are so destructive. And because they are so destructive, from a military perspective, you are forced, you have no choice. I want to underscore it doesn't mean you're crazy or insane. I know many soldiers who understand the effects of nuclear weapons who are not at all crazy. In fact, they're very reserved about using nuclear weapons because they understand what I'm about to describe to you. But because these weapons are so lethal and so capable, as a military planner and decision maker, you have no choice but to, as quickly as you possibly can, try to destroy the enemy's nuclear strike capabilities. You don't have a choice, because if you wait for the enemy to strike you, they will destroy your strike facilities before you can destroy theirs. So you have this problem that informed, non-insane, uh, perfectly reasonable, sensible people will get caught in a confrontation that they have no choice but to escalate within. So this is a social and political and military consequence of a technical fact. So keep that in mind. So here's a simple map of Able Archer, and uh, so in this particular scenario, Russian forces or Soviet forces were advancing. They had advanced well into West Germany at this point, and there was a decision made that they had to be stopped. And what what the Western Alliance was going to do was to use a small number of tactical nuclear weapons. These would have been weapons that would have mostly been delivered from nuclear artillery. So, so if you look at the bottom of this blank map, you'll see a pale uh, pink kind of circle that would indicate the location of. For simplicity, we'll assume that almost all of the weapons were in the 10 to 15 kiloton range, which was the case, and those would have been tactical nuclear explosions. So what happened is, as you see, there were about maybe 11 or so tactical nuclear artillery weapons used in order to cause a pause of the Soviet advance. And they were used mostly on the line between East and West Germany. Note that the weapons fell in West Germany because the postulated Soviet advance had already moved from East Germany into West Germany. And this is day one of the attacks. So, very early in the attack, 24 hours into the attacks. By day two, the, the Soviets had responded. Now you see, there is a much larger number of tactical weapons being used. These are in the, 1 to say 10 kiloton range. I'll show you shortly what the effects of one of these lower yield weapons would be. But for now, I just want to show you uh, the um, the numbers of weapons. Then, so this is day 2. So we've already in 2 days gone to, 30 or 40 or 50 Hiroshima and Nagasaki sized nuclear detonations. Um, Day 3 involves now the use of 75 to 100 kiloton nuclear weapons. So those, if you look down at the bottom part of the document, the map, these would be called theater nuclear weapons. These are basically, I'll assume they're 100 kiloton weapons because that's a good round number. So here are a bunch of tactical nuclear weapons. Notice these are Western tactical nuclear weapons. These are used against advancing Soviet forces. The idea is these forces, you want to stop them before they reach the front line and continue to overwhelm your disintegrating front line. So these are weapons in the 75 to say 100 kiloton weapons. Notice that there is a smaller Soviet response of 100 kiloton weapons, but that is accompanied with much larger 800 kiloton or so nuclear weapons, 1 megaton, call them 1 megaton nuclear weapons. So these 1 megaton nuclear weapons are on all of these German, basically cities, and actually Dutch cities as well, because these are hubs of logistical support. And so in the case of the Western Alliance, there are only a few Polish cities that are hit, but because they are logistical sources. But this is day 3, so it's what you say 72 hours after the first nuclear weapon. Well, actually, it's uh, yeah, 72 hours after the first. By 96 hours, we have weapons used all along, uh, all into Poland, and so this is day 4 of the attacks. And notice these weapons all along this line of of attack. These are 100 kiloton weapons. These are big nuclear weapons. And why are they along this line? Because there are river crossings here. And as I'll show you later, the fact that you have bridges on these river crossings required that nuclear weapons of rather high yield be detonated to destroy the bridges. I'll show you photographs from Hiroshima and Nagasaki that show even though the cities were completely destroyed, the bridges over the rivers were not. So when you look at this from the point of view of the military planner does not want to destroy the little village that happens to be the home of these bridges, but they have to take the bridge down to stop the enemy advance. So you have all of these weapons being used. Plus, up here in the north of Poland, you have a big port facility, and you want to stop the reinforcements coming in through that facility as well. So this is day 4. So 96 hours into the attack. So basically, this is day 4 of the situation. And we look at day 5. Here's the situation. By day 5, hundreds of nuclear weapons are detonating all over Europe, Great Britain. It turns out if we look further, we can go to Paris, London, Amsterdam, Rotterdam, Brussels is destroyed. Every major German and Polish city are destroyed. Sweden, Belarus, and the Baltics have been hit. Japan, South Korea, the Philippines, Singapore, and Hawaii and Alaska have already been hit. So the next step is general nuclear attacks by each side against cities and military installations in the US and Soviet Union. So by day 5, we have escalated to general nuclear war. What you're looking at on the map here is only the piece of the nuclear war that is associated with strikes in Northern Europe. Northern Europe was the match, the kindling location for the situation that led to the general escalation. So, uh, so if we now ask, what do these detonations look like? I mean, let's try to understand. These are little circles on a map. So I thought I'm trying to illustrate the size of these nuclear debris clouds because that also intuitively gives you some sense of the physical scale of things. So if you look at this diagram uh, in front of you, when you have clouds where you have rain, you typically have clouds that are at a little bit over 2 to 3 kilometers in altitude. There's stratocumulus clouds and nimbostratus clouds. These clouds are typically high altitude rain clouds. You can also have cumulus clouds. If you look up in the sky, you get a feel. You can see the bottoms of the clouds. So I put this diagram in here for your audience's intuitive understanding. If we show the general size of 100 kiloton and a 1 to 2 kiloton nuclear weapon, so this weapon on the left would be an artillery shell that's delivering a low yield nuclear weapon, a very lower yield by a factor of 10 than most of the weapons that the little pale pink dots, pink circles you saw on the chart. So these are debris clouds from a very small nuclear weapon. This is a 100 kiloton nuclear weapon. So this would be a debris cloud from weapons of the size of these weapons here. So these would be 100 kiloton nuclear weapons. These would be 10 kiloton nuclear weapons. Or these would be 100 kiloton nuclear weapons. I'm sorry. So lots of 100 kiloton nuclear weapons, and and these would be 10 kilotons. I'm sorry. So these would be 1 megaton nuclear weapons. So these are much higher yield weapons, and I'll show you very shortly what those weapons look like. So just to give you a sense of what an actual radioactive cloud from a nuclear detonation looks like, this is the radioactive cloud from Hiroshima. And what I've done is labeled some nimbo stratus clouds. So these are rain clouds that were above the area. And down below here, you can see black clouds. That is clouds from combustion. The fire was initiated. This debris cloud is probably about 7 or 8 minutes old. So it's still going to be rising for many minutes after the attack. This is what this cloud looks like after about 8 minutes. And what's important here is you can see there is this separate region of black smoke, which looks distinctly different from the region of white cloud, which is condensation particles, water particles and dust particles with water attached to it. These are smoke particles. And what they are they are being sucked up and they're buoyantly rising from the area of combustion on the ground. And as I'll show you, this is the beginning of a mass fire that is of extraordinary intensity on the ground that has the effect of raising air temperatures in the streets to above the boiling point of water and wind speeds to hurricane force. Here's another example of the cloud. This is from Nagasaki, which also was affected in the same way. So, so this gives you some sense of what these debris clouds could look like. And here what I've simply done is show you the 100 kiloton clouds. So that's the clouds that are, the larger circles, and then the largest circles are the 1 megaton clouds. Now, note that 1 hour after their detonation, this cloud contains 1,000 times more radioactivity than the Chernobyl release contained. So that's one day, it's 20 times more radio. So the radioactivity decays at a very rapid rate. But 1 hour after this detonation, some of this material is already on the ground, falls to the ground. And as this cloud of debris moves with the wind and the radioactive material drops in decay, still 20 times more radioactivity than the Chernobyl release. Let's say, this is one day, 24 hours later, assume a low wind speed, like a low average wind speed of 10 miles per hour. That means 240, 400 kilometers downwind, there's a cloud that's spread out now relative with 20 times more of the radioactivity of the Chernobyl release dropping particles on the ground. So you have a real radiation threat from just this cloud here. And of course, it's a much larger threat, 10,000 times more radioactivity an hour after the attack. The cloud is higher, so it will fall at, the amount of radioactivity the percent will take a longer time to reach the ground, but it doesn't have to be much to create an extremely dangerous and lethal environment on the ground. So, so what happens is this debris cloud that I'm showing you now, one day is like 300 or 400 kilometers down range. This radioactive cloud spreads and drops this lethal material onto the ground. So these are just, I won't go through them because if people want the slides, they can get them. But this is the reason why 100 kiloton blast might be needed in a small city. This is Nagasaki. I'll talk about it later. This is after the effects of the bombing, so you can see it's swept clean of all buildings. But notice that the bomb, 22 kiloton bomb, dropped in this location here, and the blast pressure was about 40 pounds per square inch on this bridge. The bridge wasn't knocked down. So if the average person looks at this, you would be horrified. At least I expect you would be horrified, as I was when I first saw this diagram, horrified by the complete destruction of everything in the city, which was done by the combination of blast and fire. The fire is what, in combination with the blast, is what's led to the complete destruction of everything that you can see in this diagram here. But the bridge is still standing. So if you're the military planner in West Germany, and you know that this bridge is still going to be standing, what's going to happen if the Soviet armies are going to rush through this area after you have dropped a low-yield nuclear weapon? It's radioactive, but they can hunker down in their vehicles and come across the bridge as fast as they can, minimize its war, so minimize their exposure, and you may not be able to stop their advance. So what you do is you go to these 100 kiloton nuclear explosives that I showed you in the earlier diagrams. This is just shows you um, a rough estimate of what of the lethal areas uh, created. This is shown in red by uh, uh, 100 kiloton nuclear explosions. So remember that in the case of Poland, there were lines and lines and lines of these 100 kiloton nuclear weapons, and of course this is also the case in West Germany and in the western parts of Europe. This is just this is not an attempt to show what actually would occur. In reality, the whole area would be covered with radiation that's lethal. Everything would be covered with radiation that's lethal. So there wouldn't be any place that you could go except underground if you had built shelters. A partial rendition, only a very partial rendition of radioactive clouds from some of the bigger nuclear weapons. And these clouds show you the mostly lethal areas produced by detonations, the higher yield detonations that would have occurred on cities. And of course, there would be hundreds of smaller clouds produced by the 10 kiloton detonations and by the 100 kiloton detonations. So this whole area would essentially be a radioactive wasteland by the time the conflagration had finished. I will not go through this. These are radiation charts for those people who are interested. They'll be in the slides if anyone wants them. This is an image of an unfortunate man who is dying from the end stages of radiation poisoning. He may have been exposed to radiation probably weeks earlier. So he was not exposed to the maximum level of radiation that would be the exposure levels of most of the people of most of the areas I showed in the earlier maps. So he was exposed to enough radiation that he was feeling okay he probably initially felt sick for a few days. He then started feeling better. So there would have been a period of time where he was feeling not as sick, not relatively okay, but a little weak. And then he would have started bleeding from the interior as his gum, you can see him bleeding from the gums here and into his skin. And he would have died of massive internal hemorrhage because one of the consequences of radiation poisoning is that your blood, the blood of a victim, will no longer coagulate. And so you die like a hemophiliac would die, just massive internal bleeding. And this is the kind of death that many people on the lower end of the exposure scale would suffer within a few weeks of exposure. People who were exposed at higher levels would suffer this kind of effect earlier, maybe within days in some cases, maybe within weeks. So there would be people dying for weeks and days after their exposure to this extreme radiation. Now, let's just talk about the least dangerous consequences of the attack, which is the blast effects from the fireball. I'll just give you a little bit of exposure to that. But let me underscore, as I hope I've already made clear, the consequences of radiation and fire were far more serious a danger and a killing mechanism than the blast itself. And you'll see that the blast is nothing to be ignored. What would happen is the nuclear detonation might be detonated at some altitude over the target area. The altitude could be very low or somewhat high. I won't get into a detailed discussion of why one does this. Basically, the reason one does this is you have uh, a primary blast wave that's generated from the fireball itself as it expands rapidly outward and compresses a shell of air as it rapidly expands outward. And that compressed shell of air then propagates on its own outward, as shown by this line here. So this is what's called the primary shock. There's a secondary shock, depending on the height of burst, that's generated from the primary shock by reflection off the ground. In this particular diagram, this is the reflected shock. And the reason you might adjust the altitude is because the secondary shock and the primary shock coalesce into a shock front called the Mach front. And by carefully adjusting the altitude of burst, you can increase the overpressure on the ground depending on the maximum range of overpressure you want to produce on the ground. This particular diagram produces the largest area where a 15 pound per square inch of overpressure occurs. So, but you know, that these are technical details that really are largely irrelevant because the blast is not the primary killer, as I hope I've already made clear. This is a picture of the early fireball from the first Trinity nuclear tests that yielded about 25 kilotons of explosion. So that was roughly twice the yield of the bomb that destroyed Hiroshima and roughly the yield of the bomb that destroyed Nagasaki. The bomb in Nagasaki was 22 kilotons. We know that. Notice that this is 6 thousandths of a second. So this is a low yield weapon. So the fireball is much smaller than the higher yield weapons. I won't go into a discussion of scaling at all. But notice also that the winds at speeds of maybe at a blast overpressure of about 6 pounds per square inch, which might occur at 2 kilometers range, is about almost 200 miles per hour. So, and this is because the shock wave itself is very long in duration relative to the shock wave you would experience from a conventional explosion. Here again, you can see the effects of the primary and secondary shock coalescing here. This is the primary shock moving outward, and here is the primary and secondary shock coalescing at lower altitudes. Here you can see in what appears to be unphysical behavior because it's traveling at a higher speed than the shock wave. That's the combination of the primary and secondary shock. But that's because the shock wave in the ground travels faster than the shock wave in air. So the air slap is causing this material to blow off on the ground from the explosive effects of the shock wave that's propagating through the ground and an effect called thermal popcorning. The light and heat from the fireball at this distance and time from the nuclear explosion is probably about 100,000 times brighter than the sun in the desert at noon. This is occurring at a very short time. And what happens is when the rate of heating is so high that grains of sand on the ground are heated at such a high rate that the heat at the surface, the temperature at the surface is enormously higher than the temperature in the interior because the heat is coming in so fast. And because it heats at the surface so quickly, and it's a brittle material, it just pops into dust, into thermally heated dust. And that's what you're seeing here. This is called thermal popcorning. If you know what popcorn is, it's an effect where the particles just explode thermally. And here you can see the fireball continuing to expand. And I won't spend a lot of detail on this. Here again, you have the distance has changed quite a bit. Notice that the stem is quite broad now because you have this circulating, rising hot air from the detonation itself. Keep in mind that this is an explosion, a test explosion in the desert. So you do not have combusting material below. So you will not see this black cloud that I showed you following up across the stem from the combusting material on the ground because there's nothing combusting. It's just exploded sand. That's what you're seeing. Superheated, exploding sand blown up by the thermal heating, thermal popcorning, and the blast wave as it passes. So here it is at still a later time. I'm showing you, here's the fireball at the 6,000ths of a second. This is at 9 seconds. So this is quite a long time but it shows you how the fireball has expanded to a size roughly the dimensions shown here, many hundreds of meters, and it's buoyantly rising volume of hot air, creating this circular mushroom cloud. And here's the fireball at 500ths of a second, and then again, here's the blast wave that's produced. A cartoon of the blast wave. Now notice that the blast wave is a shell of compressed air. It's not just a front of shell of compressed air, it's a shell. So it has the effect of enveloping its target because the blast wave lasts fractions of a second to seconds. In fact, it tends to last a second or more. So 1 second is a long time for this thing because the speed of sound is 1,100 feet per second. So it's 300 meters per second. So if it's passing over you and the shell is hundreds of meters in width, it's going to be pressing on the entire object for periods of tenths of seconds to seconds. So here is a sequence of events. So keep in mind that what we're showing now is we're seeing the initial light from the fireball. So the fireball is not yet as bright as it will be. So it's going to get brighter. And this is going to occur in this particular case in a few tenths of seconds, because this is a low yield nuclear weapon test. This is done by the United States. So now we see this is at about 1 or 2 tenths of a second after the fireball has lit up. What you're seeing now is the front of the building burning off. Of course, the light would shine in through windows and it would set off curtains, interior structures, upholstery, chairs, all kinds of internal. So this place would be on fire in the following seconds where I'll be showing you the effects coming. Then, in this particular case, it would probably be maybe a couple of seconds later. So we're talking about the first few tenths of a seconds here. The fireball has expanded. It is not yet finished producing the shock wave at this point. So we're just seeing the light of the fireball ahead of the shock wave that it's still producing. So then in about 2 seconds, we're not yet seeing the shock wave. and then the shock wave arrives. Notice that the shock wave is tearing the top. Here's the front of the shock wave. This is about 5 pounds per square inch. And notice that the front walls of the building are buckling. This is as the shock wave arrives, but the shock wave is going to envelop the whole structure. So here we see the shock wave beginning to envelop the structure, and you can see the top of the roof is coming off because it's accompanied, the shock wave is accompanied by 200-mile-per-hour winds. So the front of the building is buckling from the initial shock. The winds are beginning to tear the building apart. And we can see that as the shock wave continues to pass by the structure, it looks like the top of the building has been hit from the top by a gigantic mallet. You can see the roof is just caving upward in both cases by the crushing effect and the wind motion. And then as we look forward, the building just explosively disintegrates. Now, in this case, this is what the building looks like after the test. So you say, well, why is anything still there? Well, nothing would be there in a normal situation because this thing would have then burnt in a violent fire that would have lasted for hours in the city. You'd see nothing but ash in its location. But this was a test in the desert. So this building was covered with asbestos shingles. There were no internal materials to catch fire because that was intentionally removed, because the purpose of the experiment was to measure the effects of blast on the building. In fact, the effects of fire were ignored for decades in the assessments of the effects of nuclear weapons on cities. This did not come into the forefront of American awareness of the public until I wrote a paper in I think it was 86 actually, called the effects of superfires on civilian targets. This effect was ignored until it became advertised through this article, which was widely circulated because I presented this as the lead article in a National Academy of Medicine forum in Washington. It got into the newspapers. It was discussed in the Congress, and people started asking questions at the congressional level. Why do the civil defense people not include fires? So this had a major effect, I'm glad to say, on the perception of the true effects of nuclear weapons on our society. But when I say our society, I mean Western Europe as well. And there's a lesson here for your audience to keep very clearly understood, that this effect is now widely understood because of the accident of my opportunity to present a detailed and clear discussion of this effect in a forum that was widely being monitored by leading people in our society, a National Academy of Medicine forum. Otherwise, it would be ignored, and the general public would still be being misled into believing that these nuclear weapons are much less lethal than they actually are. Those of you who want copies of that article, also send an email. Please send a separate email, though. Title the article, Superfires Article. And I will send you a copy of that article from the National Academy of Medicine study. And it describes in great detail the effects of these superfires. And it made a big difference. I'm very pleased to say, but I also don't want to pat myself on the back too much because it was an accident of circumstances. Okay, so the unique effects of the extremely intense light and heat from the fireball have only in part been described. I just want to describe those before I end my discussion and give you some sense of how shocking these effects are. They're shocking because they're outside of human experience. So you think you understand that this intense flash of light and heat is a bad thing. Of course, that's easy to say, but it's much more shocking to understand some of the actual physical consequences. I'd like to show you those, and then I'll end it there. But my purpose of showing you this is to give you a more visceral sense of these effects so that you won't forget about them, because it's easy to focus on the blast effects because that's something we think we understand, but the fire effects are far more consequential. So so what I'm talking about is the intense light and heat from the fireball. So here's an example of what occurred at Hiroshima. Uh, the this is not will not give you a visceral reaction, even unless you're a person who understands the character of what you're looking at, and most people wouldn't. But in this case, this was a tile where there were other tiles on top of it, and the part of the tile that was exposed to the light and heat from the fireball is blistered by its exposure to the light and heat. And the reason it's blistered is similar to the reasons that you have this thermal popcorning of sand from the extremely intense bright light from the fireball. So what happened here is the intense light heated the surface of this slate to such a high temperature, a couple of thousand degrees, and beyond melting point of metals, and it just disintegrated, it just popped. But that was because it was a brittle material. So again, informative but not astonishing. This might astonish you. And I chose this photograph because it's astonishing. Here was a child. She was playing, obviously, and she happened to be in the middle of a jump where she was jumping over a rope that was strung from this fire hydrant, water hydrant, at the time of the explosion. And what you see is her shadow on the wall because the light and heat from the fireball fell on her body. And because it fell on her body, it did not fall on the wall. On the wall, you see the brick is of a much lighter color. That's because the surface of the brick kind of exploded off from the exposure to the intense light and heat in a similar way to the slate, the piece of slate I showed you earlier. But in this case, it's a much more dramatic example of what the light and heat from the fireball can do to people in a target area. Here is yet another example. Again, what you're seeing, it's less dramatic, but should be at this point, I hope, shocking, because what you see is the blistered paint on the metal wall of behind this valve stem, and the valve stem produced a shadow from the fireball, and because of the shadow, the paint was not blistered immediately behind the valve stem. This was how the early people, early the Japanese scientists who came in early after the atomic bombing in 1945 determined the height of burst of the nuclear weapon. I was privileged to know a man, Motohiro Kimura. I met Moto in his senior years, and he was involved in measuring the height of the atomic bomb. I met him when he was visiting my laboratory when I was still doing science, visiting from Japan. A wonderful man who taught me a lot from his personal experiences as a scientist in Japan. Here is another shocking example of the effects of light and heat from the fireball. I don't think I need to describe it much to you. Again, the paint on the wall was blistered, but the ladder and the person standing in front intercepted the light. And of course, the person was severely burnt and certainly died after the attack. Here is another shocking example of how the light from the fireball can affect an object. In this particular case, we're looking at a material that's obviously light and dark material, strips of dark material and strips of light material. Now, the light from the fireball, when it fell on the black material at certain points, caused the black material to, the fact that the material was black meant it preferentially absorbed the light from the fireball and burst into flames, while the white material reflected enough light that it did not burst into flames. So here is an effect where you can see the actual color of the material had an effect on the way the material reacted to the bright fireball in a way that you can understand, but of course is shocking, or should be shocking, if you weren't aware of this kind of effect. Here again, you see this effect on sheer white material. This material was covered with little flowers. I think the next slide shows them. Yeah, here's a flower up close. And here the flowers were preferentially burnt out. The material surrounding the flowers was lighter and a very light material and white. And so it reflected enough light and heat that the material did not raise to a temperature where it burnt. But the flowers were dark enough in color that they were selectively ignited and burnt out from the material. This is almost I don't know, an image of evil, if one wants to take it that way. And here, of course, are the consequences of a woman who had some kind of material with a pattern on her, covering her body when the weapon went off. And the material preferentially caught flames and burnt her on her skin. And you can see that some parts of the material reflected enough light and heat that she wasn't burned. But of course, you can see she was severely burnt. This unfortunate woman would have certainly died from the combined effects of severe burns on her body, which lead to infection and death, and radiation exposure, the flash of radiation, gamma rays and neutrons from the explosion, which caused her to have radiation sickness. So here again, the combined effects of having her immune system depressed by radiation exposure, and of course the shock of severe burns, which then leads to infections, made the effectiveness of killing from the combined effects of the bombs much greater than would otherwise have been the case. Here is an example of another unfortunate woman. In this case, you can see her skin was burned through her clothing, but she had some kind of strap. She must have been carrying something, and the strap was thick enough across her shoulder and her back, that she was protected from the effects. So just to reemphasize the effects, this is Nagasaki before the explosion, and here it is after the explosion. Note again from the earliest part of this talk, if you were looking at this from the point of view of a military planner, you would say, my goodness, the bridge is still there. The Soviets can still use it. We need to hit that bridge. And it's the fact that these blast and radiation and thermal effects are all distinctly different in their scale, but all there leads to this horrendous Hobson's choice that a military planner has to face, even if they are not crazy and even if they are well informed of nuclear effects. So, for those of you who want to understand my psychology, me as an individual, this is the image that immediately jumps to my mind when I hear about people talking about nuclear war. The people who talk about nuclear war who know nothing about their physical effects, they have no idea what they're talking about. I don't mean this to be insulting, but anybody who talks about nuclear war as a tolerable thing to deal with is simply uninformed. And if they haven't taken the trouble to understand the facts that I put forward in this briefing, and they are in a decision-making role, a political decision-making role, I make the judgment, that's my personal judgment, that these people are irresponsible and they shouldn't be allowed to be in a decision-making role if they haven't taken the trouble to inform themselves. So I have a very strong moral judgment here, as well as a technical statement to make in this discussion. And I'll leave you to contemplate what I've said from here on. Thanks for the opportunity to talk.
Yeah.
We're human beings again.
Well, I had a question about the consequences of this military exercise, because
Yes.
the Able Archer exercise in 1983, it did convince the Soviets that it was merely a cover for a first strike attack, and
Yes, that was a secondary, da very dangerous consequence that I did not discuss. Yes.
yeah, so this is why we almost ended up in what was supposed to be an exercise in an actual nuclear war,
Well,
and
what about the exercise would have been, in fact, real,
yeah.
a reality.
Yes, sadly so, and that's why I was curious. The technical part aside, this lack of fear and lack of understanding for the counterpart, how do you see this? Because often one needs to be really close to war before they really willing to take a step back and realize how close we were. And I always found that Reagan was a fascinating case study of this, because after almost triggering nuclear war in 1983, he wrote in his memoirs that he was genuinely surprised that the Soviet leadership considered it even a possibility that they might be under first strike, because from his perspective, they should have recognized that the United States was a good country, one which was virtuous, would not engage in such attack, and this should have been obvious to the Soviets. It's interesting from the what's in the literature referred to as a security dilemma sensibility. That is the ability to put ourselves in the shoes of the opponents and see the threat from their eyes.
Well,
Well,
I give Reagan very high marks for understanding that he was dealing with something that was existential, which he did not understand earlier. But I don't blame. I blame the system for not informing him of the existential effects that would accompany any use of nuclear weapons, because of the rapid escalation that is essentially guaranteed because of the nature of nuclear weapons. I give the system a zero minus mark. And this is my concern today. And that's why we are having this exercise. You asked me to speak about this because we agreed that this is a problem. You recognize this problem, and we both agreed that this is a problem. But the real problem is that the systems that support political leadership, our supposed intelligence people, our supposed military advisors, do not tell these people in decision-making roles what they need to know. Everybody who has any decision-making role at all with regard to nuclear weapons should see the talk I just gave. You should have, let me give you an example of a very disturbing personal experience I have had multiple times. I have given talks, not quite this talk, but talks about nuclear weapons consequences. I used to give this talk, not this talk, but a talk similar at Stanford University when I was teaching there before I went to MIT. And it was a very large audience at the time I was giving this talk. There was a lot of interest in arms control. This was the 1980s when there was global public interest. We had hundreds of students at our lecture every year. And every year I would have one or two soldiers who were on leave at Stanford come up after the lecture and tell me that they were involved in nuclear targeting. Uh, you know, that they had been involved in nuclear targeting, and they had no idea what the secondary or the primary effects of these weapons really were. They were at Omaha, Nebraska, the Strategic Air Command headquarters. They were involved in targeting. I knew Strategic Air Command headquarters because when I was with the Navy, before I went to Stanford, I had responsibilities that took me out to Strategic Air Command, and I was aware that the soldiers doing the targeting, were basically being told, here's a little circle and put it, figure out where to put it between these targets. They didn't know what the effects of the nuclear weapons were. They had this little circle that they were asked to place on the targets. They had no idea what the consequences of the nuclear strikes would actually be. And to the credit of these young and moral soldiers, when they saw the consequences, they felt compelled to come up after my talk and talk with me. And I had nothing but sympathy for them. And I comforted them as best I could. I said, look, you were doing your job as a soldier. That's the system we have. I will be the first to tell you that this system is inadequate. That's why I'm at Stanford now and no longer in the Pentagon. I chose to leave because I wanted the freedom to be able to inform the public about the consequences of these nuclear weapons. And that's all I did for my first few years in the public forum. It was later that I started talking about missile defense and all these other important issues, because that was my job as a scholar on these matters. But my early days after I got out of the system, got out from under its yoke, was to try to inform people, soldiers as well as civilians, about the horrendous consequences of these weapons. And I I know that the soldiers I worked with did not have any idea of what they were doing. And I don't blame them for it any more than I blame Ronald Reagan. The system does not inform them. And this is one of the things that political scientists who talk about the prisoner's dilemma, like I hear at Stanford, this nonsense, these guys talk about, they have no idea about what they're talking about. I'm not talking about you, Glenn, because I know that you are a serious political scientist, but I deal with these people at Stanford who are theoreticians. They don't learn the facts, but they have theories. And they don't understand what the consequences of nuclear use are, but they have the prisoner's dilemma and blah, 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 blah. And they don't understand what they're doing and they don't choose to inform themselves. And this is one of the greatest dangers of the American political science establishment. European political scientists are of a different culture. The scholarly culture in Europe is different, although I'm afraid you have your victims of that culture too, but nothing like you see in the United States. And these people, particularly at Stanford here, think they are the highest form of political theorist. You know, John Mearsheimer, he's a dirty guy. He has just dirt all over his feet, doing looking at details. But they are above it all. And these people are, in my view, among the most dangerous people because they talk to political decision makers. And this is what we have in the top tier of the US government. These people are not informed. And it looks that this is exactly the same problem in the political leadership of Europe.
Well, it seems that to a large extent, among the political leadership at least, the fear of nuclear weapons is all gone. But the threats, they're certainly not gone. So I wanted to ask you what do you see the main threats moving forward? Is it the proliferation, more countries acquiring nuclear weapons? Is it a change of the weapon systems? Is it the development of missile defense system, which could convert nuclear weapons um, from a defensive weapon, same for deterrence, to more of an offensive weapon? Well, what do you see? Where do the main threats come from over the
Well,
next few years?
well, I think all of the above. I'm sorry to say. The American preoccupation with missile defenses uh, has two disastrous consequences. Uh, Actually, we are seeing the disastrous consequences as of 2002, when the Bush administration withdrew from the ABM Treaty of 1972. And in essence, the Bush administration uh, destroyed the whole structure upon which arms limitations was constructed in the second half of the 20th century, because the ABM Treaty of 1972 was critical to the arms limitation treaties that followed. That includes the Intermediate Nuclear Forces Treaty and the Strategic Arms Treaties and the START treaties and all these treaties, because the ABM Treaty of 1972 explicitly, right in its preamble, talks about the fact that missile defenses create the perception that an adversary might be able to strike and then respond by defending themselves against retaliation. And the perception that this could be possible is enough to cause everybody who is looking at missile defenses of the other side to respond by expanding their offensive nuclear arsenals. So the ABM Treaty was critical to limiting missile defenses to a level where neither side could in any way anticipate any utility to those missile defenses, and thereby they could comfortably engage in nuclear offensive arms reductions. This was the holy grail for arms reductions. This was the key to arms reductions. Now, moving ahead with American missile defenses, which we have done after abrogating the ABM Treaty, and I include my Democratic friends, I want to who made it far worse than the Republicans made it, because the Aegis system is a far worse decision than the decision to build the ground-based missile defense was, because the Aegis system has all these interceptors, all of which can do nothing. The Aegis system is worthless as a technical capability, worthless. But if you're a Russian military planner, you look at it and you say, what are the Americans going to do next? They're building a foundation, and I don't know what they're going to do with that foundation at some future time. And of greater importance than the capability, if you listen extremely carefully to Vladimir Putin, and I listened carefully to Putin, when he speaks, I'm really up there with my ear to the word for word, because I really want to try to understand what's going through his mind on on the subject of nuclear retaliation. And the message I get from listening carefully to Putin is he's not afraid that the Americans can build a missile defense with any capability. He's afraid that a bonehead American political decision maker could think that these missile defenses we have some capability and take an action that could lead Russia to have no choice but to retaliate. And the Russian retaliation, he understands, would result in the destruction of Russia along with the United States. So his main fear is American ignorance combined with missile defense. And he's smart enough and well informed enough, in my judgment, from everything I've heard him say, to understand that these missile defenses will never provide any capability. But he is not sure that an American political decision maker is well informed enough that he won't be misled into believing that they have some capability. And that is the same outcome as a mistake leading to a nuclear exchange that ends both Russia and the United States and civilization. So he understands these missile defenses. So missile defenses are a big problem. So there are other questions of proliferation, but I'm sure I've taken a lot of the time here, so I don't know. But this particular one is really of quite great importance.
Yeah, and it sounds very, again, missile defense. It all sounds very defensive and non-provocative, but uh, uh, even the most competent missile defense shield, they wouldn't be capable of actually stopping a Russian first strike, given the amount of weapons, and
Or a
Russia would
second
choose.
strike.
Yeah, but this is why the concern is often that it's intended as an offensive weapon, because the best effectiveness it would have would be to intercept not the Russian first strike but the Russian retaliatory strike after a first strike. So again, whatever survives. But I've heard the same in Moscow. That was a key concern is that if the US would have a potent missile defense system, that it would perhaps delude some leaders, because if they believe that they would have the capabilities to do first strike, doesn't mean that they would pursue this, but it would create a more aggressive posture. The belief that one would have escalation dominance, that is, one can intensify, escalate the conflict, knowing that at some point the Russians would have to more or less capitulate or withdraw. And certainly when we're in a high stake situation such as we're now in Ukraine, um, if the American side would believe that they had a functioning missile defense system, it could very easily spiral out of control. I mean, we already don't seem to fear nuclear weapons, and yeah, this could make it much, much worse.
Well, if you want to get another insight from me, or a view from me of why I think these so-called policy experts who work for the president are such a group of absolutely dangerously ignorant people, look at the reaction on the American side to the Russian deployment of this system they call Poseidon, this underwater submarine, robot submarine, which probably carries a 50 or 100 megaton nuclear warhead, because the size of the space inside that torpedo is obviously large enough for that yield of a warhead. And the reason that Putin uh, showed that device to everybody, I mean, you have to be a fool to believe that he was sitting there and that a cameraman happened to be looking over his shoulder and nobody stopped him from videoing it. The reason he showed that device is he wants every American political decision maker, no matter what they believe about missile defenses, to understand that the United States and Western Europe would be destroyed by this underwater weapon where missile defense can play no role if a nuclear attack is executed against Russia. That's the reason for Poseidon. If you want to make, oh, the Russians are more inhuman, they're animals, they don't care about life the way we do, all this garbage that you hear out of these cold warriors who are totally ignorant about who the Russians are. I mean, I find, I mean, I have friends in Russia. I find it insulting. I'm insulted as an American when I listen to them talk about my Russian friends. You know, it's incredible to me, but that's why you have Poseidon. Poseidon is there to tell the most ignorant of these people I have suffered listening to that you better not do this, because if you do, you're going to be dead and your country is going to be gone, no matter what these missile defenses can do, even if they work as well as you, in your delusional understanding, think they can do. That's why Poseidon is there. I don't think it was an accident at all.
No, you're probably correct on that assessment. My last question was just in terms of upcoming disruptions or threats. We've spoken in the past about the US planning to deploy these new missiles to Germany. Now, of course, it's given the a bit of a fragmentation within the NATO alliance, but also Trump has made comments that he wants to reduce the nuclear weapons between US, Russia, and China. It might not happen, but as it stands, there's still this proposal that the US should deploy these missiles in Germany in 2026. Do you see this still going forward? And if so, what will be the main consequences
Well,
and predictable reactions from, well, primarily the Russians then?
well, first of all, this is part of the reason I'm going to Germany to speak on March 24. And incidentally, I'm going to go back to Germany as many times as people want to hear me. I mean, I'm going to talk everywhere that people want to hear me about the consequences to Germany if these weapons go back into Germany in 2026, because the situation will mirror the situation of 1983, and Germany will be the ignition point for the global nuclear war that will be more likely if those weapons are put into Germany. And I'm going to state it that starkly because that's the truth. That's absolutely an accurate, honest statement of what will accompany those deployments. Now, my own guess, can only guess, is that uh, if Trump succeeds with the Russians in normalizing the relationship between Russia and the United States, and it looks to me like so far the American team is doing a good job in that direction. But there are many problems they're going to have to face, especially from European leadership, which is completely out of touch, and large parts of the American political establishment, which is maybe as much or more out of touch than the European leadership. So he's got to fight. He's got a big fight in front of him. He can count me as an ally on that, but I doubt he would. But in any case, and one of the things that responsible Americans should be talking about is what the character of arms control agreements should look like during this normalization process. And one of the things that should be part of the normalization process is a re-establishment of the INF treaty. There's no reason if we're gonna talk about strategic arms reductions of the kind that Putin's team has already raised as a possibility, the INF treaty should be reestablished with at least the same level of priority as arms reductions. And that means the United States should cancel this extremely ill advised deployment, which is a consequence of the recklessness of the Biden administration. If you want to say Biden was reckless, here's an example. Anthony Blinken and Jake Sullivan, these people, I don't know how to begin to describe how reckless these people were. I mean, I just have no words for it. And we need to stop what they started. And if Trump wants to stop what they started, this INF treaty needs to be the same, at least the same priority as the nuclear arms reductions. Now, having said this and criticizing the American establishment, let me start with my friends at the Bulletin of the Atomic Scientists who don't return my phone calls. The Bulletin of the Atomic Scientists, which claims to be concerned about arms reductions, has said nothing about the Trump initiative. Nothing. Instead, they have published these idiotic articles about why it's a terrible thing that Trump is moving ahead with these agreements. These people who are the keepers of this clock that's supposed to be telling us what the danger of nuclear war are not listening to anybody because I can't get a phone call through to them. And I'm angry because I've written for this organization for 40 years. And if I sound angry, I am. And they are not doing their job. They should be reporting what's going on in the Trump attempt to normalize relations with the Russians, and they should be talking about the INF treaty as well. And I hope some of them or one of their audience is listening and talks to these people and says to them, you are not doing your job as a responsible carrier of the nuclear clock. You need to get out of your little club and start listening and thinking. I'm sorry to say this. I hope you will not cut this out of our discussion because this needs to be heard in the United States. Anyway.
No. Well, I spend a lot of my time worrying about the rationality of
Yes.
especially the European leaders because they all seem to think we're in some middle of a rerun of World War II, and every political discourse ends up with a reference to Hitler. It's
Yes.
just they think again they are that the Russians are the new Hitler. They get trapped in their very strange narratives where they obsessed that Ukraine has to join NATO because Russia would never dare to attack NATO. And then in the next breath, they're saying, well, we have to stop Russia now because after Ukraine is going to attack NATO. It's just, 1 second the Russians are backwards fighting with shovels. The next, they are all powerful and ready to engulf all of Europe. I mean, it's just, yeah, you wonder always, are these people genuine? Are they misinformed uh, or are they just deceptive? I'm not sure. Hoping for, yeah, stupidity or belligerence, what is best. But it's certainly concerning that they're not able to formulate a single argument without talking about Hitler. It's yeah, very, very concerning, especially when we are now fighting a proxy war against the world's largest nuclear power.
Well, let me tell you, I was quite angry when I talked at the UN and the German UN representative accused me of having chutzpah. You probably know what that means. Chutzpah is kind of like you have nerve. You know, it's a Yiddish term for you're a nervy guy. I found it uh, annoying. I would say to the extreme. I'm from a Jewish culture. Incidentally, my wife is a Catholic, so I'm kept under control. Uh, and um, and for the German representative to use that term when you look at how Hitler took control of Germany, because the political leadership did not know what it was doing at the time and allowed him to take. That's the concern about Hitler that current European German leadership ought to be thinking about. And instead of invoking his name as if after he's got power that he should never have gotten, they ought to think about doing things now where they put Germany in a situation where the same consequence occurs because of their bad leadership. That's where, if they want to bring up Hitler, they ought to start thinking about it, because the history starts with his takeover of the German political system, not with what happened afterwards, because there was nothing to do after he took over.
Professor Postol, you've been very, very generous with your time. So yeah, I just want to thank you again, and yeah, I hope we can discuss related issues in the future. So thanks again.
Thank you very much. I appreciate the opportunity to talk with you. I learn a great deal every time I listen to you.